Good afternoon, everyone. My name is Aryan Tapkire, and today I am going to share my presentation on the topic high dimensional data, dimension reduction, and parallel coordinates. Now, what is high dimensional data? High dimensional data, where the number of features or covariates can be larger than the number of independent samples, are universal and are encountered on a regular basis by statistical scientists in both academia and in industry. A majority of the classical research in statistics dealt with the settings where there is a small number of covariates. In other words, is defined as data in which the number of features p are close to or larger than the number of observations n. The opposite is low-dimensional data in which the number of n far outnumbers the number of p. Now, what is dimensionality reduction? As you can see in the picture, dimensionality reduction is the process of reducing the number of features or dimensions, as we can say, in a data set while retaining as much information as possible. This can be done for a variety of reasons, such as to reduce the complexity of the model, to improve the performance of a learning algorithm, or to make it easier to visualize the data. Components of dimensionality reduction. There are two components mainly for dimensionality reduction. Number one, feature selection. Smaller subsets of features are chosen from a set of many dimensional data to represent the model by filtering, wrapping, or embedding. There are three main features of feature selection, which are filter, wrapper, and embedder. Next, feature extraction. This reduces the number of dimensions in a data set in order to model variables and perform component analysis. Methods of dimensionality reduction. There are various methods used for reducing the dimensionality of objects, which include three most primary rules. Number one, principal component analysis (PCA), linear discriminant analysis (LDA), and generalized discriminant analysis (GDA). Principal component analysis (PCA). Now, what is PCA? Principal component analysis (PCA) is a popular technique for analyzing large datasets containing a high number of dimensions or features per observation, increasing the interpretability or understandability of data while preserving the maximum amount of information without tampering with the structure and enabling the visualization of multidimensional data. Now, PCA or Principal Component Analysis is a supervised learning algorithm that is used for the dimensionality reduction in machine learning. To sum up, Principal Component Analysis, or PCA as we know it, is a way to bring out strong patterns from a large and complex datasets. The essence of the data is captured in a few principal components, which themselves convey the most variations in the dataset. Now, let's talk about parallel coordinates. Now, what is a parallel coordinate? A parallel coordinate plots map each in the row in the data table as a line or a profile. Each attribute of a row is represented by a point on the line. This makes parallel coordinate plots similar in appearance to what we see as line charts, but the way the data is translated into a plot is substantially different. A parallel coordinate system is constructed by embedding a set of parallel axes into Cartesian coordinate system, the one we study the most in maths geometry. Multidimensional points are represented by lines intersecting the parallel axes at the respective coordinates. Overall, to sum up, parallel coordinates is a visualization technique used in computer graphics to represent high-dimensional data in a 2D or 3D space. It involves plotting each data point at a connected line segment that passes through a set of parallel axes, while each axis representing a different variable or dimension of the data. In parallel coordinates, each line segment represents a single data point, and its position along each axis corresponds to the value of the variable represented by that axis. The line segments can be colored or labeled based on additional information about the data, such as a categorical variable or a class label. Finally, parallel coordinates can be useful for exploring relationships between variables and identifying patterns or outliers in higher dimensional datasets. If you have any queries, thank you.